How about now? Oh! Hello. I see my voice on the screen. I'm new to this. I've put a live share link in Discord if you want to join. And if you want to join the audio, that's on as well. I think. Oh, don't talk to me about training, mate. Oh, you're joking, Mark. You're not in the park? Alright then. Right then. This is for Stacy because he's having issues trying to get sprites on the screen. I don't know what's wrong with my chat. Alright, only one line's showing. I don't know why. Must be a setting. Yeah. So if you wanna join my live share, it's there, right? We're ready to go. Just log into VS Code, download the live share extension, log in either with a Microsoft account or your Git account, and you'll be able to log in. Yes, I know, mate. I've been reading it. So what we're going to do is we're going to take excuse me, this. We're going to use your sprite, especially this one. Oh yeah, I know. What was that? Oh, I've been followed. Oh, I've been followed. Hello, follower, whoever that. So, we're going to use this. This is Stacy's Hunchback Sprites V1. And we're going to try and get them on the screen. See if we can animate him. And see if we can control him as well. As Stacy's not quite sure about how to do the sprite and the outline. So it's going to be a very basic one, this. So it's going to be just a basic machine code routine that hopefully will have him walking backwards and forwards by the end of it, and hopefully he's doing his legs going as well. So we have got 1, 2, 3, 4 in both directions. 4 sprites in both directions. So we'll try and use them all. And hopefully we'll have him going backwards and forwards for you. Alright. Right. Straight into kick. Now, I've cheated a little bit. I've already created a constants file. Yeah. I've created a constants file already. You're trying to join the live share? Well, I think RE's on. Yeah, I think he's in the live share. Yeah, that's him. So I must be working. I think you have to have a GitHub account or Microsoft account, I think, to log in. It's in read-only mode anyway. Yes, mate, I'm still learning that, but I've just done this because... Now, mate, glad to join. This, if you look at this, it's an exact rip of my Neptune lander. No. It's a direct rip of my Neptune lander, so I've just used the constants out of that. But yes, I've heard about that virtual page command. I'm still reading up on Kik, so I'll get there. So what I've done... it's alright, mate. What I've done... So I've just... If you look in the Neptune lander project, you'll see a file called constants.asm. All I've done is nicked that and converted it to Kik. Because we're going to use these names that reflect the things that we're going to be using. So that's the reason why that's there. And our example is going to go there. So the first thing we need to do is we need to import our constants file. And what on earth is going on? Here. Get off. It's doing it again. What? Go away. Thank you. Right. First things first. We need to import the constants file. And I've only been reading this up today. I'm not in edit mode, or you guys are not in edit mode. Oh, yeah. It's got all this new functionality when you go into live stream. It's confusing me. Right, so we're going to nick wherever it is. Or have I shut it down? Oh, it looks like I have. Okay. We're going to nick the hello world out my website. Off the forum. So we're in assembly stuff, coding, Kik, coding examples, hello world. We'll just nick that. And we'll paste it in there. Right, that's our starting point. That's alright, mate. That's alright. So, if you've got everything set up, Control F5 should assemble it. And of course my antivirus kicks in. Here we go. So this is fired C64 debugger inside a tool that one of my forum users has written to make it nice and easy on how to use it, called C64 Debug GUI, and I'll be doing a video on this because it makes life a lot easier when you're using C64 debugger. But as you can see, hello world has turned up, so I know I'm on the right track. Alright, here's your Hunchback file, and to create the sprites.bin, you just export it as a raw file. Just say raw data, none of that. Export it, and then you export it to this directory and it shows up in the list. Someone's joined. Excellent. So now, sprites. We all know sprites can be difficult to understand, but there's a certain rules that you have to remember. 1, set the sprite pointer. 2, enable it. 3, move it so you can see it on the screen. They're the 3 common mistakes I've seen so far where people are trying to use sprites. Yeah, I see. I've just accepted you, mate. Trying to use sprites and they can't see it because they've missed one of those 3 steps, which is set the pointer where the sprite is. I've lost my train now. Yeah, make it enabled so you can see it, and then move it onto the screen, because by default it's in the top corner of the screen. It's alright, mate. It's in the top corner of the screen, so it's at 0.00, so you have to move it so you can see it on the screen. And every time someone says, oh, I can't get a sprite on the screen, it's one of those 3 things. So what we're going to do is, we've got your bin file here. So this is where all your sprite data is, because I've just exported it. And what we're going to do is we're going to import it at a location that I'm used to, which is, so we're going to tell the assembler to jump ahead, and we're going to import it at 2A80. And if you wonder what I'm looking at Neptune Lander. Cheers, mate. Thanks for that. So we're going to call this sprite data, and the way to import it is dot, and look, I'm at that page because I was reading about it before I come in. Is dot import binary, and the name of the file, which is sprites.bin. So that tells the assembler where to put that binary data. Doors opened. Now we've got to reference it, and the way to reference it is, all sprites are 63 characters, but the Vic references it every 64 characters because it's a power of 2. So what we have to do is 2A80, let me get the calculator on, we have to convert that into decimal and then see what the sprite pointer is. And I'll show you what I mean by the sprite pointer. So 2A80 is that. So divide that by 64 should give us 170. So that is our sprite number. That is the sprite number of the first sprite. So with that, if you look in the constants file, I've already set it up. So we're going to make the first sprite come on the screen. So like I've said, we'll put it in there so we get it to say hello world, and then we'll add all the other stuff to it. So here we go. So the first things first, load the sprite number. LDA. I've forgotten what it's called. Oh, Sprite RAM. So that's our number, that's 170, and we're going to store it in, if we look at the constants file, I've actually got the first sprite pointer referenced. Yeah, sure. How do I do that? That better? Oh, Control X. Is it? Control Plus. Oh. Oh, you learned something new. Hey. Right. So we've loaded the sprite pointer, loaded the sprite number, which is 170, and we have to put it into the first sprite pointer. Now I've got a reference to the first sprite pointer, which is here, which is 07F8, which is just off the screen RAM. So we'll copy that and we'll paste it into here. So that's now set, told the VIC chip, where the data for that sprite is in memory. Thank you. So, step 1, we've told the VIC where the data is. Step 2 is now we've got to enable it. So, to enable it, if you have this book, it's page, good question, 132, 33, 34. People are walking behind me. So on 140, it's called SP Enable, SPENA. So we need to set that. Now I've set a constant called that, which is here. Oh yeah. And so we're going to load we've got to load a value that enables the sprite. So now the way this works is have I got something I can write on here? Yeah, that'll do. So what we've got is a bit with 8 bytes, a byte with 8 bits. So 1 2 3 4 1 2 3 4. Now, the sprite enable byte, each bit tells the VIC chip to turn that individual sprite on. So, sprite 0 is there, bit 1. Sprite 2 is bit 2, 3, 4, and so on until sprite 8, which is there. And so what you do, you put a 1 in it to enable it, and a 0 on it to make it disappear. So we're looking at sprite 1, so we need to enable that bit there. Now, because we're only messing around a little bit, we're going to directly set it. So we're going to say put 1 into the sprite enable location. Yeah. Next thing, the third rule is put it on the screen. So an ideal location is 0.60 in both X and Y. So we're going to load A with 60 and we're going to store it in X and Y, and I've got some, so this is sprite 0x and sprite 0y. This is the high bit, and we will get to that later. We're not going to confuse the matter. So we're going to store 60 in X and we're going to store 60 in Y. Yeah, no problem. So, the 3 rules. Let's get rid of this. The 3 rules. Load the pointer. Tell the VIC where the data is. So it's the memory location divided by 64. So in this case, it was 170. Store it in sprite pointer 1. Put 1 in the enable byte. That enables, in this case, Sprite 1. Put the X and Y location into Sprite 1. I know it says 0 because it's 0 to 7. It's all, you know, it's, you know, machine code. And we're putting 60, which should be in the top corner somewhere. Now, let's run it. Let's see if I've got a sprite on the screen. And I'm not talking utter rubbish. Here we go. Control F5. Come on. There we go. Hey. Doesn't look much, but there he is. You still with me, Stacy? Yeah, Mark. You still with me, Stacy? Are you? You're not lost? Right. Now, as you saw, it was just a white shadow of his former self. So we need to get the, because I noticed in, where is he? Here, he's in multicolor mode. Yeah, because you've got a tick on. So we need to then activate. We need to still activate the multicolor part of the sprite. So the multicolor part is called, the memory location is here, Sprite multicolor. So we need to set that, and that is the same as if we did the enable. So we can do store 1 in that, and that will turn Sprite 1 into multicolor mode. Alright? And so we need to set the colors. So we've got, where are we? So we've got the sprite color at 10, which is pink. Okay, pink, 10. Alright, so we're going to load 10. And we're going to store it in the sprite color location. So if you look in the constants, I have actually got those there. So sprite color is, where are we? There we go, Sprite 0 color. So that's the first sprite color location. So we're going to store it in there. So that's setting the sprite color to be 10. So that's that pink. Then we need, so multicolor 1 is a mucky brown color. So that's that brown. So brown is 9. So we need to store, so we'll load 9 and we're going to store it in the multicolor 0 byte. That's there. And then the other one is green, which is in multicolor 2, so that's 5. So we'll store 5 in multicolor 2, which in Vic's sense is multicolor 1, because they like to be confused, everybody. So we'll store that there. Now, if I run this, what I might do though, is I might clear the screen first. Let's clear the screen. So LDA hash $93. Is that clear screen? 93 is clear screen, isn't it? And we'll send it to there. I think 93 is clear screen, isn't it? Someone help me. 93 clear screen. Where's the pesky codes? You can't remember. Cheers, mate. Clear screen 147. We'll go with that. Right. So we're going to clear screen. It's going to print hello world, and hopefully we're going to have a multicolored sprite. So here we go. Control F5. Come on. Yay! Celebratory drink. So now we have got Quazzy in his glory on the screen. How are we doing? Still with me? Stacy, still with me? Yeah? No problem, mate. Not a problem. Welcome. Now, Stacy hasn't answered me yet, so we'll wait. We'll carry on. Yeah, okay. So now we are going to try and put his outline on. Right, so this is the overlaying that you had a problem. You didn't understand, right? And don't worry. Even sometimes I get it wrong. I got it wrong when I was doing Neptune Lander. So we need to put this on top of there. So you end up with something like this. Now, what you need to do is you need to activate another sprite to do this. Okay? So what we're going to do is we're going to activate Sprite 2 to put that on top of it. Alright, so let's go back here, get rid of that. So we're going to activate another sprite. Now, we have to work out what sprite number it is. So if that's 170 in this current project, so that's 0. So this is Sprite 8. So that must mean it's 178. So what we need to do is set another sprite pointer to 178. So this is what we're going to do. So we're going to set to say that this is +8, and we're going to put it in the next sprite pointer. So the sprite pointers are a series of bytes. Sprite 0 is that location, Sprite 1 is +1, and then 2 is +2, +3, and all that, yeah? Here, we are, that's comment, yeah. We are loading that into the Sprite enable and the Sprite multicolor. But the problem is, you don't want this one to be multicolor. So we've got to make sure we don't set the multicolor byte, yeah, for that sprite bit to make it multicolor. So we need to split this out, right? So we'll do that like so. But this one needs to be changed because now we need to enable a second sprite. So we need to enable this one here. So that's the binary version of 3. So that's now activated our second sprite. But if we ran this, we'd not see it because it's, like I say, it's off the screen. So we have to do the third rule, which is to put it on the screen. So that easy. We'll just copy these two, and we'll just add 2. And the reason why we're adding 2 is because Sprite X and Sprite Y are 2 bytes next to each other. So it's a word, yeah? So for the next sprite, it's 2 bytes down. Alright, so X plus 2 is Sprite 1X, Y plus 2 is Sprite 1Y. And then we need to set its colour. So we need to set that sprite colour, and that sprite is black. Yep, black. So we need to do here LDA 0 and store it in here +1, because remember sprite 1 is, that's the sprite 0 location, we're adding 1 to it. We're not bothered about multicolor. Right then, that should work. Here we go. Oh, so close. Ooh, so close. Right. Now, the problem here is there's a Z order, and sprite 0 is always at the top, I think. Why did I close this book? I don't think it changed the Z order. Can we? Can we change the Z order? Anybody? I don't think we can. Oh, shut the book again. So, we can't change the Z order. There we go. Yeah, I don't think so. And so what happens is sprite 0 will always be on top, and then sprite 1 will be underneath. Sprite 2 will be underneath that. Sprite 3 will be underneath that. Sprite 4 will be underneath that. So what we need to do here to make Hunchback have its definition, or the black outline and stuff like that, we've got to swap the two sprites over. So we've got to make the multicolor sprite sprite 1, sprite 2, and the outline sprite sprite 1. So it's very simple change. Yeah. So here we're going to say now the outline is sprite 1 and the multicolor is sprite 2. We're still enabling both sprites, so that's alright, but now we are going to multicolor that way. So we need to put 2 in there. So the X and Y is the same, but the colour is going to be different because we've flipped them over. So we'll swap them over. The multicolor is the same. I think that's it. So we satisfy the 3 rules. Tell it where the data is. Put it on the screen. Enable it, and then put it on the screen. So here we go. Control F5. We should now have a fully defined Quazzy. Come on. Ooh. Have I got my numbers wrong? Oh. Blank. Yeah, broken one of me 3 rules. There we go. There you go. 1 Quazzy. It is really, really good, isn't it? Now, that is a normal size sprite, and we could blow it up if we wanted to, which we're going to do because I want to see it on the screen really good. So there is an expand X and an expand Y byte that we have to set, and I'm just going to do it just for the moment. Where is it? Oh, where is it? I thought it was expand. Where's my book? Anybody know the locations of what X and Y make them big? Ah, here we go. So it's D017, which is not there. So we'll put it in. And it's called Y expand. So that's Y expand and X expand, wherever that is. You'd think they'd put them together. There we go, D01D. And it's expand. D01D. Right, so here we are going to just do this. Store that in Y expand and store it in X expand. So we that's what it's there for. That is what it's there for. Right, so that should now blow up Hunchback and make him big so we can see him on the screen. Let's do this. Control F5. There we go. There we go. So now we have got we have got this dude on the screen. So it's so now it's just a case of if we want to move him, if we're going to do left and right, yeah, because that's all we've got the sprites for. So we're going to get him walking left and right. So we need two things. We need to be able to read the keyboard and then change the position. So we need some sort of loop so we can go round and round and round and round and round. Now the standard sort of looping thing is to wait for the raster to go off the end of the screen and then do all the work, which we've done in Neptune Lander, but I haven't got the libraries in here. So what we'll do is we'll set up a looper. So game, and that's how you do a label, I think, yeah. And now I'm going to go into Neptune Lander and try and nick the code. Screen. So where's the library? There it is. So that's it. So we're going to test for 240. I think that's the end of the screen. And we're going to go to game looper minus. So this, whoops. So this should test for the going off. So it should test for it going off the screen. And so what we're going to do is we are going to. Oh, the indentations all over the place. We're going to increase the border. Border colour, that's that one, isn't it? The game loop is where you're going to be running through the same bit of code all the time. It's the looping of the game. We're going to try and simulate that, because we need to loop to be able to test the keyboard, to be able to understand what's the key that's currently being pressed, and then act on that key. Yeah. So we've got the sprite on the screen. Yeah. So now what we need to do is to try and move him. So what I'm going to do is I'm setting up a looper that's going to go round and round and round. It's going to test the keyboard. It's going to find what key we're pressing, and then we're going to act on it by making the sprite go left or right. Yeah. And so normally you would test for the end of the screen and then do your code. And we do this in Neptune Lander. Both Mark has done it, I've done it. And it means that you don't get any artifacts on the screen, because if you could be running your program and telling it to move, and the raster could be halfway through it, so you end up with a sprite that's broken. And this way it allows you to affect the sprites, and then when the raster comes back down the screen again, it's already been done. So that's what we're going to try and do. That's why I'm increasing the border color, to see that, one, I'm starting it in the right place, and two, to see how much time it's going to take to do it. Well done, mate. Well, there you go, Stacy. Be able to read what he's going to be saying in the next couple of days. So, but for this example, I thought you might want to be able to get him moving, yeah? Get him moving left and get him moving right. And then once we've done that, the next task was to try and see if we can get him walking, yeah? So that's what we're going to try and do. So, question. How are we going to test the keyboard? Well, we're going to use Peak 197 of all things. It's the simplest and the easiest, so that's what we're going to do. So what we're going to do is create a label, keyboard test. And we're going to load 197. Now 197 is a byte that stores all the keyboard scan codes. So we've got 64 keys on a Commodore machine, and each one has a specific number. So and that's where 197 comes in. And so in the constants I have all the keyboard scan codes, which are here, look. So let's see, what keys do we want to use? J and L, left and right. Sound like a plan? Okay. J and L it is. So A and D. Okay. Yeah, we'll do A and D for classic. So what we need to do is we'll load in the byte where the keyboard code is, and then we're going to compare it with none, and I think that's 64. Here we go, scan code no key. If it's equal to that, then we send it back to keyboard test send it back to keyboard test, because it means no key was pressed. Yeah. But we're in a loop, so really I need to make it I need to send it there. So we're going to do not equal, because it's going to be a long. So we're going to call this test for a key, and we're going forward, and then here we're going to jump to game loop end. which is going to go jump to game looper. And I know you're all going to go, why are you doing that, John? It just makes it look nice. Here we could tell it to go back to the game looper. I've been looking at Jeff Minter's code too much. He does that, doesn't he? Okay. Right, so now we need to test for the A key. So test for A key. So we're going to compare it with, there it is. And if it's not equal, we are going to test for B key, D key, which is going forward. And here we will jump to update Quazzy, and we'll go forward. Yeah, no, don't need to. No, we don't need to. Good call. Yeah, you're right. Good call, mate. So we're going to compare this with D. So I've made them all the same. Branch if not equal to game looper, because it means that we wouldn't have found the keys that we want. Yeah. And so here, jump, update Quazzy. Now, we haven't written the update Quazzy routine yet, and what we need to do is we need to tell the system which way it's going. Yeah. So we will we'll have a byte location. And what should I pick? Where's my spare bytes? Where's my spare bytes? That's it. O2A7. That's a spare byte. Nope, that's not used. O2A7. So what we're going to do is we're going to create another label here. Quazzy direction. Call it O2A7. So that's alright, mate. That's what I'm here for. Right, so D is going right. So that means we are going positive. Yeah, so we're going to load one and we're going to store it in our new location where we're going to destroy. So this might, so A is the other way, isn't it? A is the other way. And this one is 01. So we're now setting a byte that's going to tell our update Quazzy routine which way it's going to go. So here. So we'll set this is the routine now. So we're going to load that. We're going to compare it. We're going to do one of Shallan's things. It's branch if minus. Now branch if minus is I can explain it. Branch if minus. Quazzy Osborne. Right, branch if minus tests this bit is a result of that bit. If that bit is 1, then branch if minus will fire. If it's 0, branch if plus will fire. So we are testing for this bit because we're actually setting it at 255. I mean, I could have set it to 128 really, but branch if minus is a quick way of testing if the last bit is set, and if it is, that means we're going D. D is going left, so that means we're going to be going left. So going left. So if we have stripped out one of the two outcomes of that byte, which is 1 or 255, the other one is that we're going right. So we don't need to test that we're going right because we've only got two possible outcomes, left or right. So we've tested for left, but now we're going to perform the right. So basically what we need to do is we need to load Sprite 1 X, and we need to, in fact we can do this cheating. We can load X with Sprite 1X, increase X, store X in Sprite X, and again in Sprite X plus 1 because we've got two sprites on the go. Right, and then we'll jump back to the game loop. Yeah, we'll jump back to the game looper because we've done it. We've made him go left. Go right. So now we're going to go left. Going left. And we do the same thing again. The only difference is but there's 2 bytes, mate. I suppose. Let's do it. Get rid of them. Yeah, because we're only moving in 1 pixel. We're only moving in 1 pixel, aren't we? So that should be it. Right, my OCD's kicking in. Right, so that's a routine. Right. This is why I wanted the game looper end. Never mind. We'll just... no, we'll leave it. Right, we'll see what happens. What? Are they not comments? Stand here, mate. Oh. Down there. You saw nothing. Why did that not compile with that? Doesn't it like... Oh, it's going the wrong way, isn't it? No, that's right. Game looper backwards. Why is it not like that? What? Right, that's must be a temporary thing then. Those temporary labels must have to do that with temporary labels. There we go. Oh, psychedelic. Alright then, AD. Let's see if he moves. No, he don't. Oh, I'm going to have to take that off. Where's the dump? Here we go. Is 10 D 18. 18? Did it do 18 for D? 10 12 16 plus 2 is 18, yeah. Okay, why is that not moving them? Why is that not moving Quazzy? Well, that doesn't help. That should be working. Hang on. Stop. Thank you. Right, let's put a breakpoint there. 10, go. F10, go. There we go. Did it? Okay. Go back to full mode. Full mode. Control F1, I think. There we go. F10, 11. Oh, I've crashed it. Might have to run it in the, not in debugger all the time. Right. Hey. Hey! Right. Let's put it, make it run in. Let's make it run in device. Right, Control F5. Oh, it looks different in Vice, doesn't it? Wow. Okay. We got a super duper Quazzy. So, what we need to do, right, what we need to do now is, he's alright going that way, because he's pointing that way. But we need to, when he goes in that direction, we need to get him, we need to turn him around. Yeah? So we need to get him to turn around. Alright? And we need to do it for both ways. So, we need to modify the code to do that. So, in your sprites, well, it's your sprite. So, there. That is the sprite number we need to make him go that way. Alright. So let's create some more labels here. So label right Quazzy right equals 170. And dot label Quazzy left 174. I think that was right. So if that's 70, 71, 72, 73, 74. So that's 174. Right, so we need to now change this update logic, and what we need to do is we need to change the sprite pointer to point to the correct sprite. So if we are going, so this is let's put a comment in here, Quazzy going right, and this one is Quazzy going left. Right. No, left. Oh, right. Oh. Was that funny? Okay. Right, so what we need to do, we're going right. So we need to load the sprite pointers. We need to... Yes, you're right. See, you're getting the hang of it now. So we're going to load. That's the sprite pointer for going right. And we're going to store it in that. Because it's the first one is the multicolored sprite. Yeah? And then we're going to load... Oops. That +8 and store it in Sprite 1 because that's where the outline is. At Sprite 0 because that's where the outline is. So we're going to do the exact same but here. But this time it's not right, it's left. Alright, still with us? So, Control F5. There he is. Are we in warp mode? Can never tell. Turn off. Here we go. That should... might not... Right, here we go. So, D. Quazzy's walking right. A. Oh, I'm loving this. How you doing? Are you still with us? Stacy, still with us? Yeah? I know you're there, mate. So now, we've... It's a really good sprite, this, isn't it? So now what we need to do, we need to get his legs moving. Yeah, we need to get his legs moving. Right, so now, because we're using the raster to good mate, that's good. Because we're using the raster, which means that all the code we're writing at the moment is off the screen, yeah? It doesn't affect the screen. Okay. What we're going to do now is we're going to... Because the raster happens 60 times a second. So what we're going to do is we're going to use the raster to count frames. And then we're going to first divide that frame number by 4 because you've got 4 sprites. Yeah. So you've got 4 sprites going in each direction. So we need to work out, have a frame counter and then divide it by whatever number we need to give us a number between 0 and 4. And then we're going to change the sprite pointer based on that. With me? I think so. I think I set the flag. Because the last one didn't say, so I'm hoping it will. So this is what we're going to try and do. So we need a frame. So we need a frame counter, and it's my first. If you don't count the test. So we need another a byte. We need a byte just to count the frames. So this one, we'll call it frame counter, and we'll set it to the next one, which is there. By the way, the O2A7 to O2FF are not used by the Commodore 64 at all. So they're free bytes that we can use as variables. Just a little trick there, little bit tidbit. So now we've got a frame counter. So what we're going to do is we're going to initialize the frame counter. And then what we're going to do is we're going to increase the frame counter every time it goes off the screen until we hit 64, and then we're going to return it back to 0. And the reason why I've done 64 is because it makes 4 into 64 a lot easier than 60. So what we're going to do, so here we are going to increase frame counter, and then we're going to load frame counter, compare with 64. Branch if not equal to keyboard test, and if it is equal, we're going to just reset it back to 0. That should do it. So that should count up to from 0 to 63. The 64th one is the one we don't want. Set it back to 0. That should do it. That should do it. Yeah. Right, so now what we need to do is first, if there's no key, we want them to stay still. Right. So if there's no key, we want them to stay still, but we want them to stay still in the direction it's going in the stand-in. Right. No, we'll worry about that in a bit. Let's just get his legs moving. Okay, so we need to work out what sprite we're on. So let's create another routine called calculate frame sprite frame. So we need to right, 64 divided by 4. 16, isn't it? 16, 32, 48, yeah. So we need to load the frame counter. So we need to divide it by 16. So that's logically shifting right. So that's divide by 2. Divide by 2. Oops. Divide by 4. divided by 8. Yeah, but it's not. It's not really. It's as long as you've got a frame counter, animation is not so bad. Yeah, because then you can link to your frame counter. I mean, that's what Derek did in his book. He had a frame counter that kept all the animation in sync. Now, you've got 4 sprites, yeah? And because you've got 4 sprites and we're now having 64 frames to play with, to divide those 4 frames, we need to use those 4 frames, we need to, and it's to use those 4 frames in 1 second, yeah? So each frame would be a quarter of a second, roughly. So what we do is we're counting up to 64 in the frame counter, but we need to divide that by 4 to give us the 4 regions to use the animation. So in fact, when we want to find out what sprite frame we want to use, we divide by 16, which will give us an answer between 0 and 3. Okay? Hence dividing by 16. It's only to work out your sprite pointer value, because you've got 4 going left and 4 going right. Yeah, ignore the outline because that's classed as 1 frame. Yeah, so you got 4 going left, 4 going right. Yeah, here 1, 2, 3, 4, and then going left 1, 2, 3, 4. The fact that you've got your outline sprite is irrelevant. Yeah, because we're using these 2 sprites for 1 frame. These 2 sprites for 1 frame. So we've got 4 sets of frames. Yeah. So we divide by 16, which should give us our frame number. Now, what to do with that frame number? Let's create another label, then we'll know what we're doing it. So we'll store that in there. So we've got the frame number, divided by 16, gives us the sprite frame number, and that's what we need. So we'll return back, because we'll make it a go sub. And what we need to do here is we need to, we can do it here, JSR, work out what our frame number is, and then here we add our sprite frame number, and then we store it there. Do the same with that one as well, there. We are only animating the one, left and right. Yeah, we're animating both sets. So we need to do the same here. So we need to add the frame to that and add the frame to that. So that should give us our frame that we're storing in the pointer. Because now we've worked out what our sprite frame is based on the frame counter. Right. Control F4, F5. Let's see if I break it. Oh, Mark's gone. Here we go. Okay, mate. There you go, mate. We have a walking Quazzy. Got walking Quazzy. Easy peasy. Yeah, easy peasy. Well, I think that was it. Don't need that. Yeah. Make sure I ain't broke it, just get rid of that. Knowing me, I've broken it. A&D, where are we? His hair moves. Right, as you can see, that is a blown up sprite. So if you want to see what it looks like not blown up, all you need to do is just take the rem out the expansion lines, this one. Yeah, so rem out that, rem out that. So Control F5, that'll give us back now the normal sprite size. There you go. Yeah, weird, isn't it? Now, if you think the animation is too slow and he needs to be walking a bit quicker, then basically it's a case of it's just basically working it out over. So let's say if we do 32, so we'll do 32 frames. So 32 divided by 4 is 8, isn't it? Yeah. So if we rem this out, 32 divided by 4 is 8. Yeah. Yes, it does. But the reason I did it big is so you could see it. 32 divided by 4 is 8, isn't it? Why am my brain not working? So we're now going to be doing it. So this should have doubled the frame rate up. This should have doubled the speed of the frame rate, hopefully. So his legs will go faster. There we go. So now we've got a Quazzy that looks like he's walking pretty quick. So this was my first stream to help someone overcome a problem. Did I do all right? I've enjoyed it. I've enjoyed it. And did the live share work? Was you watching the code change in the live share? Was you following still that way? Is it worth having the live share? That's the question I'm asking. Well, I hope you've learnt that it's not as scary as you think. If you just follow the 3 simple rules, which is set your pointer, turn it on, put it on the screen. They're the 3 simple rules. Okay. When you live share, does it copy the code onto your machine? Not sure. Okay. So who's in? Alright, okay. It even tells you who came and went. Cool. It's not... Once... Just those 3 rules, mate. That's all you need to remember. I mean, we've gone a little bit... Right, I will put it in the GitHub. Okay, I'll create a streaming... I'll create a streaming repository in GitHub for this, and we'll put it in there. I'll put it up there, yeah. So you can grab the code and all that. I wonder if I can do that now. I'll do it in a bit. I'll put it in the GitHub and I'll create a new repository. Yes, yeah. Right. So I'll put in Discord that it's in Git, and then you can download the code and look at it yourself. Yeah. Hopefully this has helped, and I've and I think we should do more of these. Just little things. Right then. So unless there's anything else, we put him on the screen. We've got him moving left and right, and we've got him animated. I think that's been a successful session. So I will cheers, mate. I will leave it with that, and now start editing a video for next week. All right. Okay then, guys. I will call it a day, and then we'll. I'm going to nip over onto Shallan's stream and see what he's up to. You're more than welcome, mate. All right then, guys. I will shut it off. I don't know all this raid stuff, and yeah. See you later, guys. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.